SpaceX genius 3D printers that make space rockets are unlike any other. The space sector is seeing unprecedented growth. Newer, smaller rocket companies continue to pop up as industry titans take their maiden leaps and crew journeys to space, contributing to the growing frenzy to get to space faster, cheaper, and better. One of the new companies, Relativity Space, based in California, has great hopes to 3D print its way into space, and they're getting ready for its first launch. Today we're going to talk about the collaboration between SpaceX and Relativity Space to make space rockets using 3D printers. Yeah, you heard it right. Of course, this sends us all into a frenzy. How can entire rockets be printed? Will they be durable enough to withstand space travel? Is this a viable and sustainable way to build rockets in the future? Well, stick around as we answer all these questions and take a deeper dive into the world of 3D printed rockets. So let's begin the video. 3D printing for rocket engines is making a lot of headlines lately. Before we get into SpaceX and their plans to 3D print a rocket, let's start by talking about the company that is making all of this possible in the first place, Relativity Space. Ellis and Jordan Noon, both veterans of Blue Origin and SpaceX, established Relativity in 2015. Ellis worked at Blue Origin and Noon worked at SpaceX on the Dragon capsule before forming Relativity. Both had been developing 3D printing technologies for rocket parts and shared a vision of creating 3D printed rockets. The two raised money for the startup by emailing Mark Cuban and explaining their vision. Cuban made an initial investment and has continued to do so in subsequent rounds. The company's raised roughly $1.3 billion in venture capital to date, with the current round valued at $4.2 billion. Relativity Space plans to launch its first rocket before the end of the year. However, this hasn't prevented the corporation from looking ahead. The rocket company based in Los Angeles recently revealed that it has raised $650 million in a Series E funding round. This money will be used to speed up the development of the company's Terrain-R rocket, which will be entirely 3D printed and capable of carrying larger payloads than Elon Musk's Falcon 9. Relativity's first launch, scheduled for early 2022, will send its Terran-1 rocket, a two-stage entirely 3D printed rocket, into orbit in a test flight to demonstrate its viability. This will be the first launch of a rocket that's been entirely 3D printed. It's not only the world's first entirely 3D printed rocket, it's also the largest metal 3D printed object ever made. Terran-1's whole basic structure is printed and is 110 feet tall with a diameter of 7.5 feet. According to Relativity, it can deliver a payload of up to 2,756 pounds to low Earth orbit. Terran-1, the company's first rocket, is aimed for smaller payloads and will complete with rideshare flights on larger rockets as well as small launch vehicles such as Rocket Lab's Electron. The rocket's first test flight is scheduled for the end of this year, with commercial launches following soon after. There has been a lot of interest in Relativity's rocket launches. Relativity's first rocket is Terran-1, but the business is already working on Terran-R, which is totally 3D printed and completely reusable. Terran-R is not only reusable, but it's also much larger and capable of carrying a lot more. Terran-R is 216 feet tall, 16 feet wide, and capable of launching over 44,100 pounds into low Earth orbit. This will be a significant improvement over the Terran-1's disposable nature. Terran-R's first, second, and payload fairing will all be reusable, according to the business. In June 2021, the corporation revealed the new two-stage rocket, with plans to start launching it in 2024. Both rockets will take off from a launch pad at the Cape Canaveral Space Force Station on the Florida coast. Now, SpaceX has published information regarding their usage of 3D printing in the Dragon spacecraft's Super Draco thruster engine, as well as one of the Falcon 9 rocket's engines. The Super Draco thruster engine is an improved version of SpaceX's current Draco thruster engine, which is used to control the Dragon spacecraft in orbit and during re-entry. The crewed version of this next-generation Dragon version 2 spacecraft will be equipped with Super Dracos. They'll be used to power the spacecraft's launch escape mechanism, which is fully incorporated into the vehicle. SpaceX claims to have spent nearly 3 years perfecting 3D printing technology for flying gear. Using direct metal laser sintering, the business 3D printed a Super Draco engine chamber constructed of Inconel, a high-performance super alloy, late last year. The part was designed and manufactured in-house. The entire chamber was also successfully fired at first thrust, which is 16,000 pounds per engine. SpaceX is currently putting these engines to the test in its crewed spaceflight program. When compared to traditional machining, 3D printing cut lead time by an order of magnitude, It took barely more than 3 months from the first concept to the first hot fire test. SpaceX completed Super Draco certification testing in May, which included repeated starts, extended firing durations, and high off-nominal propellant flow and temperatures. Each Super Draco can be restarted several times if necessary. They can also deep throttle, giving astronauts massive amounts of power while maintaining pinpoint control. The Super Draco engine was successfully throttled at thrust levels between 20% and 100% during the hot fire test, according to SpaceX. It was fired in 2 different profiles, launch escape and landing burn. During a fire, the chamber was fired more than 80 times. If a problem arises during launch, the 8 engines of the Dragon version 2 launch escape system will deliver up to 120,000 pounds of axial thrust to transport the crew to safety. The launch escape mechanism also allows astronauts to land the spacecraft with the pinpoint accuracy of a helicopter utilizing power. As a result, the Dragon version 2 spacecraft is reusable and can be refueled and reflown several times. SpaceX will fly Super Dracos later this year as part of a launch escape system demonstration. In January, SpaceX flew the first 3D printed rocket engine part on the Falcon 9 rocket for the TICOM 6 mission. A 3D printed main oxidizer valve body was found in one of the rocket's Merlin 1D engines. With high-pressure liquid oxygen, the valve worked properly, despite significant vibration and cold temperatures. The printed valve body has higher strength, fracture resistance, and ductility than a traditionally cast part, as well as less material variability. It was also a lot quicker to make, taking only 2 days to print instead of months. All Falcon 9 flights will now be able to use the valve. So are you guys enjoying the video? We've discussed SpaceX's 3D printed rockets in great detail, but why exactly is the space industry moving towards 3D printing rockets in the first place? We have all the answers, but do you? So when you think, do subscribe to our channel and click on the bell icon to receive instant notification about all our future videos. Due to the flammability of space rocket engines, many early prototypes wind up embedded in dirt banks or adorning the tops of any trees that happen to be nearby testing locations. Unintentional explosions are a common occurrence. When a rocket engine fails, the source of the failure must be identified so that it can be repaired. The cycle then repeats itself, with a new and improved engine being designed, made, sent to the test location and fired, until the only disassembly taking place is the slow, scheduled kind. One of the key reasons for developmental delays in what is a rapidly increasing space industry is perfecting rocket engines in this manner. Today, heat-resistant metal alloys and 3D printing technology are redefining the creation of aero rockets. Structures that previously would have required hundreds of different parts may now be produced in a couple of days. This means that, as the private sector space race heats up, you can expect to witness a lot more rockets breaking up into tiny bits in the future years, but the parts will get bigger and fewer. While Relativity's first launch will see the company put its tech to the test, the startup dreams that its work will one day see the red surface of Mars. And with this recent partnership with Elon Musk and SpaceX, that dream may soon turn into reality. So are you excited to see the world's first 3D rocket take flight later this year? Let us know in the comments below. And if you want to watch more of our amazing videos, then stay tuned.